This is Mr. Herman. In this video, we're going to talk about scale factor. So in our last video about dilations, we did see something about scale factor. We're going to talk a little bit more about it now. So we saw that it is a multiplier. Whenever we saw a scale factor, we had to do some multiplication. This is what tells us how big or how small a dilation grows or shrinks. Okay, so it measures how a dilation transforms. Okay, so now we've got a couple different situations that we can have here. One of those is that our scale factor, SF, is between 0 and 1. Okay, now what that means is that the image is smaller than the pre-image. Okay, there is another possibility that the scale factor is equal to 1. And since it's a multiplier, if we multiply by 1, that means that the size is going to stay the same. So the image is the pre-image. And then the other possibility of scale factor is greater than 1, which would mean that the image is larger than the pre-image. Okay, now there is one other possibility, and that is where the scale factor is negative. And if the scale factor is negative, that's going to be a reflection, but we're not going to see those, so we're not going to talk too much about those. But there's one last thing I want us to look at for scale factor is the image is smaller than the pre-image if scale factor is less than 1. Image is larger than the pre-image if scale factor is greater than 1. We have a ratio here. So the scale factor, if we write an equation here, we have the scale factor equals image over pre-image. Okay? Scale factor equals image over pre-image. So let's go ahead and take a look at a graph. Okay, this is similar to what we saw in our dilations video. We are looking at our image is A, B, C. And then our pre-image, our pre-image is A, B, C. Our image is A prime, B prime, C prime. So we already know that our scale factor is going to be less than 1. Okay, so if we think about our equation, we want to put anything from our image in the numerator, anything from the pre-image in the denominator. Okay, so let's take a look at a point. We have A is 3, 3. 1, 2, 3, 1, 2, 3. And we have it going to A prime, which is 1, 1. So our scale factor equals A prime over A, which is 1 over 3. Okay? Now, if we were to check for B prime and B, C prime and C, or even check a side length, that should be the same thing. Okay, so this length right here from A prime to C prime is 1. This length from A to C is 1, 2, 3, 1 over 3 again. If it's an actual dilation, it should be the same scale factor the whole time. Okay, let's take a look at one other situation. We are given side lengths. So we've got a triangle here. This is going to be our image, or pre-image rather. And then here is our image. Okay, so we remember our scale factor equation is, image over pre-image. Now, the key here is to make sure that we have corresponding parts. Okay, so these two triangles here, we're kind of making an assumption, but we have to make sure that we'll have to look at our labeling. In this case, though, we have 3, 4, 5 triangles are pre-image. Our image is 12, 16, 20. It is safe for us to check 12 and 3 and 16 and 4. We're actually going to do that so that we can confirm that these are similar figures, that these have the same scale factor rather. We need to make sure that we check it with all of the possibilities. Okay, so we're going to show that they are the same. So if we have 12 over 3, 16 over 4, or 20 over 5, and we are correct because 12 over 3 is 4, 16 over 4 is 4, 20 over 5 is 4. Since all those scale factors agree, that is in fact the scale factor. All right, now I've got a few questions to answer regarding the scale factor.